Assalamu alaikum students. In today's Zoom online class, we discuss the groups in the periodic table. So in the summary now, I am just revising the main definition of the topic. So the groups, they are defined as the vertical columns from top to bottom in the periodic table. They are called as groups. So the members of the same group having the same number of valence electrons. Here I have mentioned the example of group 1A of the periodic table, which are commonly known as the alkali metals. So here I have mentioned the first 4 elements which are the part of this group. So by means of the electronic configuration, here you can see that all of them, these 4 elements having 1 valence electrons in their outermost shell. So the group number, it indicates the number of valence electrons of every element present in it. Then because of the similarity in the number of the valence electrons, the element shows resemblance in their chemical properties in the same group. Clear? So the similarity in the members of a group in their properties is because of their different characteristics. Groups are divided into subgroup A and subgroup B. So the subgroup A are called as the normal elements, while the subgroup B, they are called as the transition elements. So here we discussed the 8 groups of the normal elements, which are basically the subgroup A, and they are comprising of group 1A to group 8A. Now look at the group 1A. Group 1A, it is commonly known as the alkali metals. Their bases, these are basically the compounds. So when these metals combine with other elements and result in the formation of a compound, so they are called as the bases, and these bases, when dissolved in water, then they are called as the alkalis. All the members of group 1A, they having 1 valence electrons, their valency is +1. They are highly reactive, means they are highly electropositive. Electropositive means they has a tendency to lose electron during any chemical combination or bond formation. So their electronic configuration is NS1, which shows that all of them having 1 valence electron. Group 2A, they are commonly called as the alkaline earth metals. They are also responsible to make the bases, and their bases are also soluble in water. They having 2 valence electrons in their outermost shell. I have explained the 2 examples of members of group 2A. If we look at the electronic configuration of calcium, so in the last shell here you can see that they having 2 valence electrons. Similarly, magnesium, it is also the member of group 2A. They having 2 valence electrons in its outermost shell. So all the members in group 2A, they having 2 valence electrons in their outermost shell. All of them show the valency +2, plus representing that they are electropositive in nature. Electropositive means they have a tendency to lose electron. So all the metals, they are electropositive in nature. Group 1A, 2 and 3A members, all of them, they are metals, and they has a tendency to lose electrons. Clear? They are less electropositive than the group 1A. So it means that the reactivity or electropositivity of group 1A is more than the members of group 2A. Then moving towards the group 3, it is commonly known as the boron family. And all the members of this group having 3 valence electrons in their outermost shell, they show the valency +3, and their electronic configuration shows that they have 3 electrons in their valence shell, and it shows the electronic configuration NS2 and NP1, so which shows the representation of 3 valence electrons in their outermost shell. Group 4A, which is commonly known as carbon family, they having 4 valence electrons in their outermost shell, and their electronic configuration shows that it having 4 valence electrons, so it is NS2 and NP2. They show valency both +4 and -4. It depends upon the nature of the elements. That mostly that number 4 group, it is the intermediate between the 8 groups. So some members show the electropositivity, some show the electronegativity. So most of them, they has tendency to make the covalent bonds. Then group 5A, it is commonly known as the nitrogen family. So as the group number is 5, so it means all the members of this group having the 5 electrons in their outermost shell. they show the valency -3. So as it having 5 electrons in its valence shell, so for the completion of their octet they has tendency to gain 3 electrons, so the valency will be -3. So its electronic configuration is ns2 and np3. Clear? So with the help of electronic configuration you can easily know the number of valence electrons of each element which belong to different groups of the periodic table. Then group 6a, it is commonly known as oxygen family, or they are called as the chalcogens. So chalcogens, basically the word is derived from the Greek origin, and which means the copper former ores. Ores are basically the combination of different substances and appear in one form, and which can be represented by means of their chemical formula. So basically ores contain the minerals. So minerals can be represented by means of their specific formula. So those ores which are mostly contain the copper. So that's why the chalcogens, they are representing the term for copper former ores. They having 6 electrons in their valence shell, they show the valency -2. As all the members of group 6, like oxygen, like sulfur, they having 6 electrons in their outermost shell. For the completion of their octet, they has the deficiency of 2 electrons. So that's why they has the tendency to gain 2 electrons. So their valency is -2. Their electronic configuration ns2 and np4, which shows that they having 6 electrons in their valence shell. Moving towards the group 7a, they are called as the halogens or the halogen family. The word halogen means salt former. It means that, for example, halogens, they contain fluorine, chlorine, bromine, iodine. So whenever these non-metals combine with any metal, they result in the form of a compound which are salt in nature. That's why they are called as the salt formers. All of them having, as the group number is 7, so it means that they having 7 valence electrons, so they show the valency -1 for the completion of their octet. They are highly electronegative elements. Electronegative elements are those which has tendency to gain electron to complete their octet. So in the periodic table, among all the non-metals, group 7 is the highly electronegative elements group, and their electronic configuration is ns2 np5. So here I have mentioned the example of chlorine. Chlorine having 17 electrons. So if we write the electronic configuration of chlorine at the end, we are able to know that they having 7 electrons in its valence shell. Now the last one group of the periodic table, that is the group 8a. So they are commonly known as the noble gases, inert gases, or zero group. Why they are called as the noble gases or inert gases? Because they do not show any chemical reactivity with the other elements, because they having complete valence shell. The first member is the helium, which having the 2 electrons. So 2 electrons means that it follow the duplet rule, and rest of all the other members of the group 8, they having 8 electrons. It means that they follow the octet rule. So all the elements of group 8, they having complete outermost shell, so they do not require any electron to either gain or lose it. That's why they are inert in nature. So that's why they are said to be the noble gases or the inert gases. So the electronic configuration is, in case of the helium, that is ns2, means 2 electrons in its outermost shell, while in case of rest of the elements, that is ns2 or np6, which means 8 electrons in its valence shell. So their outermost shell is complete with the electrons. So this is all the detail about the groups of normal elements in the periodic table. So you have to learn and revise the question from your notes and read it carefully and try to learn it by yourself by means of writing in your rough copy. Thank you.